In this video, I will introduce SVAT. This is a key component in the Landyne software suite for electron diffraction simulation and crystallography analysis. The software can be downloaded from website on the screen. Just click on the cubic and you have the software appeared here. Let me introduce SVAT, the menu first, then get it into the detail. Drop-down menu of the file, including the new created new date, load the date, and also provide a demo date. Save the current work and reload the previously works, and this is out of the program. In the table drop-down menu, you have a calculate atom and experiment atom, and also space group table. In the component one, you can adjust your display for atom, for the bond, and for magnetic moment. In the display drop-down menu, you can show lattice only or with the structure, including the atom and everything. You can use a layer, structure, and projection, and you can get to show only the cluster of the structures. That's for the analyze. And you can make animation movie out of this software. In the output drop-down menu, you have a ROI, which means region of interest, and you can set up your resolution for your TIFF file. You can save the display as GIF or JPG or TIF. In the tools menu, you have can calculate the shortest bond in the structure, and you can also create a bond list. You can set a bond length, calculate the band length and the band angles. In the options, you can hide the menu toolbar. So if you monitor are small, or also you can change it to different looks and feels that have a metal and yeah, three of them selection. In the last one, you can get the current working drive and SN. We already point out this function in our first video. It's very easy. You can find out or track down to the first video. The last one is the version. You want to confirm that your version are the most dated one. Otherwise, you can always download the most recent one. Now I will show you how to create a new structure file. You go to File, New, and you have a template for your created crystal structures. Let's try. This structure is called Bismuth 2 Platinum. Is a cubic face. Then we select here for cubic, and this is primitive type, and the lattice parameter here is, and because it's cubic, B and C equals A, and O, ABC, alpha, beta, gamma are 90 degrees. This space group is limited from 195 to 230, 205, and click check symbol are correct. There are two atoms here in the independent atoms in the shell. One is called platinum. The atom number is 78. Position are 0, 0, 0. Occupancy is 1. We add on. And the second atom is bismuth. Atom number is 83, and position is 371. Y is 371, and Z is 371. Occupancy is 1. We add on. Number of atoms in the list 2, and this global isotropic temperature factor, we put 0 here. If you put larger number, Ag distance, the amplifier will be dropped down slightly. This phase exists 473 Kelvin degree. We save this file. Here you see the new buttons, which will clean out all the field for you to prepare a new structure file. You can also convert existing file from the structure file you made, or you can convert from other format like a CIF file. Let me show you. You click editor. This JCP is for the format we used before. Click next, and the one we saved last time is Bismuth 2 platinum cubic. Select this here. We open Bismuth 2 platinum cubic. Structure cubic. The type is primitive. The lattice parameter here. Space group here. There are 2 atoms here. If you want to modify the atom coordinates, you can select it and remove. And the parameter is here. You can change it X, Y, Z occupancy. Once you did it, add them back. And you can save them. So then you have a new file. Now I show you how to convert from CIF file. You click new here, prepare for it, and click editor, select the CIF, so connect next. And we have here 2 of them. One is copper oxide, one is other. Have a problem here because the CIF file have so many commands there. There occasionally have a little problem. I'm going to show you, but you can load the most part of it and modify slightly. Let's first try the copper oxide. Select it. Open. So it's automatically open all the file here. This is this description. You have a monoclinic is a C type. BC alphabet is here. Space number is here. And they have 2 independent atoms. Once you save this will save the format we can load to view the file. Let me to show you the other file that may have a little problem. We can easily modify it. Get new here, editor, and CIF is here. Next, we select the next file and open it. This file, most part of it is retrieve is good. Tetragonal here, but the lattice tab is out of order. We get a symbol, a space group is missing, and we can find out this space group is 103.7, and it's a P type that easily we can reselect here as a P. Then you have the whole file here. If you save them, you got the whole file. Most of the time the CIF works, but just occasionally that I pick this up that to show you there a small problem, we can solve it. Click out editor. We also can convert JEMS and PowerShell. If you have these 2 type files, and you can convert them. The format of the structure file is simple, and you can open it and edit in any text editor. And here I show you example. We're already in the C drive. We're in the Landyne 3 folder and structure. And click here, open this file, structures, title, the shell information, space group, and 2 atoms here, and atom coordinates and occupancy. And this is structure temperature factor. Notes is here. So you may have a problem if you re-edit this file. Format is not exactly as required. We recommended you to use the template I showed you before to create a new structure. Now I'm going to show you how to display a structure. First, let's go to File, go Load, and select the 2 plotting cubic, the file we edited before. Double click it, and now you have the structure ready here. We can change the color. Now the platinum color was so dark, and we can go to the periodic table, the config one, and I move the periodic table on the side, and we selected the platinum here. This is platinum atom number 78. The color is navy blue, so better selected aqua. Enter the color, and you can recognize the platinum here and bismuth here. If you want to reset, you can go reset. And I want the color are still in the file, and I enter. So that's for, you can also change the bismuth color and we get rid of it. So now I show you the control panel. Here are, you can see the file name here very halfway here. I can enlarge the window slightly. So this is cubic bismuth 2 plot demo file. Lattice vector that if you select it now, A, B, C here, have the perspective view of the whole structure. The operation we now select is orientate X and Y. You had to hold the mouse left button and rotate them. You can select the rotation around the Z. Z axis is from the screen, point to you, the button, and you see here it just rotate. And you can zoom the whole structure to small or get them big. You will put back to the rotation of X and Y. For the control of the atoms, that you can show the sign for the signed one, and here we don't have a platinum 1 or a bismuth 1, so the signed one will be the same as the element here. Otherwise there will be different. The signed one, you can have any name on that. Element will show you the element bismuth platinum here. And the next one is the number. The number is very important because each atom will have a number there. Once later we want to connect it, the bond between the atom, we had to use the number. And the next choice is so nothing, just the color there. And for label here black, we can select if more color on red, will be more revealing for the whatever we have for each atoms. And for the appearance, we have solid ball 1, solid ball 2, disk, and circles. Let's try to see solid ball. This is the disk and the circle will use much less memory to operation. So if you have a very complex structure, you can rotate them to make them to certain orientation that you want to show. Then you get back to the solid ball. And you can also to control the whole atoms to make them small or big. Before we're using the periodic tables to control individual type of the whole thing. Now I'm going to show you how to add the bond to two atoms. For example, we selected the atom to show them in the number. So if we want to connect a bond between atom 32 to 260, you go to bond. Let's move this to click mouse left. Move it here. First atom is 260. The second one is 33, and you want to add bond between them, and it's between them, and you can move, see, view this any directions. Let's try another one, the same one. 60 and to the bond in atom 2, not here. Atom 2 have a 2 bond there. You can add any amount of the bond to the. You can save the work and reload them like this. Add a bond, then we already have a 2 bond here. We can save it, save the current work. Call this cubic bismuth 2 platinum work. Save. And suppose that we have a reload them. We'll reload the structure so you don't see any bond there. Now we can go to reload the provincial work. That is cubic bismuth 2 platinum work. Immediately this 2 bond is there. So we can continue on this. We add 1 more bond here, and then we save them. So we add 1 more bond is 16 to 260. 260 here. So we now have a 3 bond connected to these atoms, and I can assign the bond to different colors. Now the default is gray, and if we can put a red bond there, we can do that too. So we're going to save this. Next time we can start from here. So let's save this work and overwrite this one. Save. When you study the magnetic property of a crystal structure, you may need to put a magnetic moment to some atoms. And now I'll show you how to put a magnetic moment to atoms. Let's select a different crystal here. Load. We have iron, platinum. This structure have a layer of platinum and layer of iron. Point out to the C direction, and this is in display component magnetic moment, and click your mouse left button, move to here. Again, to know which atom is which, then we selected the number of the atom. The number, the atom 32 is iron. It has a moment point to along C axis, so the atom is 33, and the direction is 001 is the C axis, and this is how strong of the magnetic moment. Usually you just put 1 there, and you put at there, and after that you can install atoms in the element here. So we have for iron, of course you had to put all of the iron there. I just do example, just put 1 there. So you see we have magnetic moment to assign to the iron atom and point to the 001 directions. And we can remove the atom vector. And again, that if you want to save this work, you can go save the current work. Now let's go back to bismuth 2 platinum structures. Sometimes you need to show students only the lattice without atom in it. Display and lattice, and now you have only lattice. Now is the cubic lattice. Here I have an animation block here. Two kind of animations here. One is rotation, one is wobbler. And speed mostly control both rotation and wobbler. Range is only control for the wobbler forever. If you want to stop this kind of action, just put a stop here. So far, I show you how to display crystal structures with a bond or magnetic moment. Now we're going to show you how to analyze your structures by presented in layer by layer or local clusters. Let's first go to display and layer and projection, and here we click mouse left button and move here. This is the whole projection along 001 directions. The feature of the structure in the projection is the zigzag atom chain here. And let's see on the side of the perpendicular to this view here. And we have a 3 red line here. Middle is mean the position. You can change the position by here. So all the 3 lines are going. Let's go back to 0. The other 2 lines is delta D is how larger the layer you want to select it. Let's move this one smaller. In this case, that's only atom in this layer will be displayed. But we see a totally different view from here. And now you can see in this layer, the platinum square have 2 bismuth inside, and each bismuth square there is 1 platinum atom there. So by this way you can analyze your structures. Let's go back to the view. In these structures, this layer and the middle layer are the same. Some complex structures you can see layer by layer and you get your result. This is 1 layer of bismuth 2 platinum structures. You can zoom it to small or big. And if we want to print out this layer of structure, I probably have to use zone of interest and also set up the resolution. And here, go to output here. This we are going to print out. This will make it nicer. We just print out the inner thin blue line. Now I'm going to show you how to generate local clusters. And we load the default structure, show the atoms in numbers. We want to find the local structure of around this atom 260s, and we put this display clusters. We put the atom here, 260s, and the distance will be 3 angstroms. Let's add atoms there. So we only find 1 atom is 360 there, and we can show cluster only here. So we remove all other atoms, and now we go to connecting the bond. The local structure for atom 260 is this kind of structure. See that we get the nicely local structure with the shell, and we can remove the shell too. Easily build. Another analyze to find out the shortest bond and the whole bond list in your structure, and also the bond length and also the angle. Let's try the first one, and let's put maximum bond length is 4 angstrom, and for search. In this structure, the shortest length is between the number 0 to bismuth 122 is 2.7705 angstrom. And the whole list you can save here. Save here. And this is the bond list. You push save, and you can find the whole list of the bond. You can also specify the only search for type 1 atoms and type 2 atoms, give atom number here. So the bond will be only platinum to platinum, or platinum to bismuth, or bismuth to bismuth. If you put a 0 here, that will mixing up all kind of atoms here. If you just put the 2 atoms here, then we'll calculate the length between them. If you put 3 of them there, it will put an angle in it. Let's put, again, you need this sign the atom to numbers. And for easily, let's find out the angle and the length between atoms 2 to 260 to 32. So from the first one to the second one, length is 2.7702. Go from 1 to 2 to 3 is 117.56 degrees. You can analyze any angle between them and everything. And selected hiding the tools here. So all you want to put is back current working drive and SN. Drop this down. So here you are, you're working on the C drive, and this is your serial number. Thank you for watching. Please check out other videos on Landyne Software Suite for electron diffraction simulation and crystallography analysis.